Hi, everyone. All right. Okay. Everyone can hear me. I guess I'm talking about something related to data today. And it's going to be a little bit of a lessons learned talk. Can I step away from this thing? Can everybody still hear me? Okay. All right. Excellent. Don't want to block my face with the screen. Oh, and a clicker. We're going to talk about how to analyze data better. In particular, we're going to talk about how to build your own in-house analytics system so that you make yourselves more productive. A little bit about myself. The strike-through has gone there. I was formerly CTO and co-founder of DataPad, and now I am a software engineering at Cloudera, working in the Hadoop ecosystem. I was an early contributor to the Pandas open source library in Python. If you've done data analysis in Python, you've probably used Pandas. And in a former life, I was a financial quant on Wall Street and also in Greenwich, Connecticut. And my passion is creating better tools to make people working with data more productive. All right, so the theme of this very brief talk is sort of split into two major pieces. The first piece is that I want to talk to you about generally what is the current state of BI and analytics workflows and what makes them painful or difficult. And when you try to build your own system or build a system for someone else, what you can improve on, what you can focus on to make things better. Right? So I'm going to make the very shocking claim that work is done by people. And when we talk about workflows, we have to therefore focus on the people that are doing the work. And when we're talking about analytics workflows, generally they involve two types of people. Business analysts who are analytical but not technical. Right? They're tasked with understanding the business, maybe understanding some statistics and math, and they're tasked with discovering insights from the data itself. And then you have engineers that are responsible for shepherding the data throughout the system. They should have a deep understanding of the infrastructure, of the details of how to work with data and how to make data accessible. And generally, the domain of these two different personas in the company is bound together by SQL. Right? You write SQL queries, or you write SQL queries through other tools, and so on and so forth. Now, let's take a look at this workflow in a little bit more detail. I apologize if this print is a little too small for the folks in the back, but let's start from the left. So in most modern businesses today, you have an amalgam of different data services that you're using, right? You might have Salesforce, you have Google Analytics. What's not on there, you might have Mixpanel, and then combine that with your own databases. So that the first step of data integration, of taking different formats and different data pieces from different vendors and normalizing it and unifying it into one enterprise data warehouse, that's done by the engineering staff. Right? And then the next step is making that data accessible. So from your own enterprise data hub, that data is generally queried via some kind of ODBC or SQL interface, and generally, engineers are often involved in that as well. The data is then delivered to the analyst. Analysts generally work as a team, right? Data science these days is no longer a solo activity. You'll have people working together. They have different expertise. They have different areas of business domain knowledge and also statistical knowledge. They work together through this data discovery process, and the results of what they discover is then made available in the form of reports and dashboards for the rest of the organization. And of course, it's never this nice and neat, and it's never a one-way linear process. Right? You might have comments and questions in the collaborative process, and what's really painful is when you get the data and you find that it's not really ready for analysis, or you need to further transform it. That, if we go back a slide here, we can see that really when a lot of analysts look at their data and say, hey, I need to do a transform, they then need to cross the boundary, and the data needs to go into a different tool. They need to pick up the phone and call the engineering team, and then they need to wait at least a few hours, if not days, before they can get new data back. right? So this clicker is a little aggressive. So what other things are, so I talked about slow iteration here and the collaborative processes being kind of difficult. There are other problems, right? So there's a little bit of a catch-22 in your ETL process. In order to look at your data, you first have to load your data into the system. In order to load the data into the system, most tools forces you to commit to a set of transforms. Right? But in order to know what types of transforms you need to apply on your data, you need to also look at the data. Right? So it's a circular problem. And of course, that whole process of shepherding data from integrating from different sources into your own in-house database to delivering it to the analyst, all that process highly dependent on programming knowledge. Right? So how do we do better? The insight that we sort of learn from building DataPad is that after many decades and many dozens of different tools, really the pain point is still in how to make data, or rather how to make useful data accessible to the analytical but non-technical folks in your organization. And specifically, if you're building an in-house analytics system, you want to make sure that you're focusing on the analysts, and you want to focus on making them more self-sufficient. And let's break that down into 3 different areas, right? Ingestion, discovery, and refinement. So the obvious thing in ingestion is that you should prefer data vendors and service vendors with the data API. Right? There are some data vendors out there today that want to lock you into their limited analytics features, and therefore they make it difficult for you to actually access your own data. You should really question whether you should be using them at all. Right? But the key thing here is that you want to build internal tools that allow you to easily pull data from external sources, right? Normalize it, insert it into your own databases. But the most important piece is you want to make that functionality available to non-technical folks. It could be a simple web-based UI that has a few parameters, and you can then select the date range and then hit a button. Or it could even be as simple as a nicely documented script that you can pass around the company. All right. And then let's talk about discovery. I think with discovery, the issue is actually finding data, or not necessarily finding data, but knowing what to look at. Right? So if you only have a few tables, or if you have a few dozen tables in your database, it's not such a big issue. You scan down the list and you find it. But with today's databases and data warehouses, oftentimes you'll have multiple schemas, multiple databases, and hundreds of tables in each one. So you want to make sure that you make tools available to your analysts to actually identify data that's relevant to the task at hand, and that could be something as simple as a search box, right? And you want to also find relevant metadata. So if they find a piece of data that's what they need, and you want to expose the relationships that are in your database, and you want to expose that to the analyst and make that available. Right? And finally, you want to make sure that all of your analysts are finding the right pieces of data. So while some of this problem, the solution to it is technical, some of it is in the business process itself. If you're a data leader in the company, you should be responsible for creating a set of practices and conventions so that if your data analysts need to find a piece of data, they know what to look for, and that they all know to look for the same thing, and so that when you have results, when you have analyses, they're comparing apples to apples. And the third big item here is refinement, right? And ETL doesn't necessarily have to be heavyweight. Sometimes it's scary because it's a 3-letter acronym, but it's not. And in fact, the transformation in this ETL process shouldn't necessarily have to happen in one place, right? And that's part of what is broken about the workflow, in that the transformations that you do on your data they generally tend to break down into two types. Right? One type is technical transformations, or transformations that are driven by technical requirements. If you want to create structure out of a semi-structured data set, for example, that's a technical requirement. But if you have, if you know that your a particular column is only between 0 and 99 or 0 and 100, then values outside of that range should be marked as bad or missing values, and that generally requires business knowledge or domain knowledge, for example. And then the last thing is that all of these transformations, especially the ones that are driven by business requirements, you should make them available to the non-technical folks as a tool that doesn't require you to actually code up or even write SQL queries. Now, unfortunately, when you do that, you kind of complicate the matter, right? Because when you allow your non-technical folks to then actually change the data, you want to make sure that you don't forget about data governance. Right? You don't want everybody in the company to be changing your database or changing your data. So this often also requires a collaboration between the technical solution and a business process. Right? The technical solution is that you need to have a set of permissions so that who can write to what pieces of data, you need to make that clear. And then the process itself is you need to make sure that people learn and understand how to write data, or when to create views, and when to actually affect the data itself. And then the last thing I'll talk about is just a glance over a few small points. Right, when you talk about transforming the data in multiple places, you want to make sure that everything you do to your data is recorded. Right? If you have a good system for recording what happens to your data inside your entire infrastructure, that's a good foundation for repeatability, repeatable workflows, provenance. Who hasn't gotten an Excel sheet with a chart that you have no idea where it came from, and that shareable workflows, and the ability to then take those saved workflows and then automate new and similar workflows. So that's the end of the talk, and I think there's some time for questions.
I'll take the first one. I'm actually curious about your impressions from the hedge fund world into the world of data science, because that's a journey that we see quite a bit here. The quants in hedge funds coming and becoming data scientists. What did you find in terms of level of sophistication on both sides?
I think I was involved in the hedge fund world from 2006 to roughly 2010, 2011. And I found that I think the level of so I think if you compare the level of technical sophistication of a hedge fund, or especially a quant fund, to, for example, an investment bank, I find generally smaller, especially quant funds, tend to be more technically advanced. However, I think I think the general practice is, I'm not sure if it's with the passage of time or just in a hedge fund. Generally speaking, the workflows were very backwards, and I think the sort of focus on optimizing your own productivity, it was just not there. I think there were a lot of one-off analyses that weren't very much focused on data provenance and repeatable workflows and so on and so forth. So I find that the sort of general data science realm to be much more technically sophisticated.
Okay, great. Do we have any questions? Yeah, one, Tony over there.
Yeah. Hi, Tony Bear with Elvum. I really liked your talk.
Thank you.
And especially when you're starting to talk about data governance and data stewardship, especially with regard to basically making sure that the data is valid. What I'm wondering is, in your mind, how does this compare? How is this, in terms of how you do this, How's this different from how you would do it in data warehousing? Because you're espousing a lot of the same goals, if not all the same goals.
Well, I think there are not a lot of products out there that would work out of the box to really do data governance. So when I talk about data governance, there's a few things. There's one, it's when data makes its way into the system, to be able to automate policies, for example, right? And then when something happens to the data, you get alerted and setting. I think the second piece is, of course, setting permissions on pieces of data itself, and that's sort of a. I don't want to say solve problems, but there's more tools and available solutions for that. And I think really comes down to metadata. And I think if you have a lot of data, whether you have a lot of data or not, I think if you're careful about recording metadata for the actual data that you have, right? So what kind of table is it? Who has access to it? What kind of what pieces of data are generally queried together? And I think if you have a sense of both the technical metadata and the business metadata, I think you can then it makes it a lot easier to be successful at data governance.
Cool. All right, we're going to keep it moving, but thank you very much.
Thank you.